Okay, well I'm going to do this one first using base 10 logs, because let's pretend you didn't know anything about base E logs, natural logs. If you want to get at this exponent here, you need to take the logarithm both sides. If I take the log base 10, because it's on my calculator, what can I do with this? This thing can go right here, right? It can go in front. So I can write this as 7k log E, and that's log 3. So then 7k is log 3, or divided by log E. And you can actually put the 7 on the bottom over here as well, right? And there's what k is. I'm sure you can work out what that is on your calculator, get a number. If you want to use base E, you can do the same thing, but it's actually going to probably be quicker because you have 3 equals e to the 7k. If I take the natural logarithm of both sides, what happens over here? This actually simplifies pretty easily, right? What happens there? Yeah, this is just 7k. 7k equals ln of 3. You can see this thing as log base E of 3, if that helps. And then you can see why log base E of 3 is equal to log 3 over log E, right? That's that change of base rule. And so k is ln 3 over 7. That'll give you the same value, whatever it is. Anybody find that value? What is it? What's that? 0.156. Anybody agree with that? So to 0.15? I guess that makes sense. 1.5, what are the other two if we're doing it to 4 decimals? Somebody speak up. 6 and 9. Good. If you're solving this question down below here, this is the one where you're solving for time in years. You're going to be, for Math 12, you're going to be given the formula. You don't have to model it yourself. Not that it's that hard to model it yourself, because the only difference is instead of, when it's growing at 3%, instead of putting 1.03 to the t, you're going to put e to the 0.03 t, and the other part's going to be the same. It's going to be 28 in front. It's little difference other than that. And the difference there comes from using this as if you're assuming that the population is growing continuously. You can set it up like this. For Math 12, this is going to be the focus though, but you have to be familiar with this other thing here. If you're solving for t there, when's it going to be 40 million? 40 million equals 28e to the 0.03 t. Whatever 40 over 28 is, I'm going to leave it like that. You could solve this two ways. You could use base 10 logs or natural logs. I am going to use natural logs because it's a more simple expression then, right? If I take the natural log of both sides, I just get this exponent over here without anything to fiddle around with because it cancels that out. So t is equal to ln of 40 over 28 divided by 0.03, and it gives you something or other. If you did it the other way, you'd end up with 0.03 t log e, and you'd have log of this, right? If you did it the other way, you'd have log of this, like from this point, 0.03 t log e, and then you continue down and solve it the way you always have, okay? So we're not going to freak out about base e, right? It's not a big deal, not that much different. Any questions about this? If I remember correctly, let me see if I got some questions in this practice for you. Probably I don't, eh? I don't. There's actually, if some of you have signed out a Math 12 textbook, there's a few questions in there. There's a couple on the unit assignment. That might be enough, I don't know.